Welcome back to the Apprentice One-to-One podcast. I'm your host for tonight, Mark, and I've pulled the team back together to speak about EV charging. So we did an episode not too long ago with myself, Richard and Craig, and we're going to revisit some of that. Before we get into it, how are you, Richard?
Very well, thank you, sir. Yeah.
I'm good, thank you very much. Not too bad at all. And we've got Craig with us as well tonight, but Craig is having some technical issues at his end, so hopefully he stays on the line. How are you, Craig?
Yeah, good, you?
Not too bad, not too bad.
Hoping that we get through this.
Yeah, I was saying to Richard while you were offline, we're going to try and keep these to around 30 minutes if we can. Just short, concise, really in-depth look at specific sections of the code of practice. So for those of you who aren't familiar, you're going to need this if you're going to tackle the EV course. It's the code of practice, 4th edition. There's probably a 5th edition on the way imminently, but I think we're still in 4th. And we're going to look at section 5, because last time we spoke a little bit about getting into RCDs. They feature quite heavily within that section. And I'm going to let you guys take the lead on this because you're the lecturers. So if we look at section 5, one of the first parts of it is page 27. It talks about the compliance aspect of it. And I guess it's looking at the protective devices we use and mixing earthing systems. Where do you typically start with that one when you're teaching your students?
So section 5 then is purely general electrical requirements. There is section 6, 7 and 8, which is a bit more specific for domestic, commercial, industrial, etc. But this is generally the backbone of, the electrical side of things that we need to have a knowledge of. So it starts off by talking about compliance with the product standard for the chargers, which is BSEN 61851. So we're hoping that the manufacturer has done everything they need to do in order to make sure that their equipment complies with that product standard. Then it starts talking about compliance with our wonderful book of information, the old 7671. So the idea of this code, or code of practice, like any of the guidance notes, is to give us more friendly, in-depth guidance on a particular section. So we know that generally this is all based upon the requirements in general of 722. So it starts talking about general compliance, and one of the biggest ones it's talking about in terms of part 4 of the regs, of course, is protection against electric shock. So it tells us to start with that we're not allowed to use obstacles and placing out of reach or earth-free local equipotential bonding as a protective measure. Not allowed. It then talks about TNC systems, which technically we haven't got TNC systems, and even if we did, it actually makes a note and references ESQCR regs, which actually to prohibit the use of PEN conductors within our installation. So I don't need to worry about that. Then it talks about a TNCS system. So we're talking here about line conductor, neutral conductor, and a separate earthing conductor from the source all the way through into our supply and throughout our installation. So a TNS system. And it tells us that unless it can be guaranteed by the relevant DNO, so your local distribution network operator, and they vary across the country, that TNS supply system is TNS all the way back to the supply transformer, and it will not be converted to TNCS as part of any ongoing network upgrades, repairs, etc. You've got to treat those types of earthing systems as TNCS because they generally are.
Yeah, it's going to be 99% of the cable, isn't it?
But yeah, so you might look at your supply and you've got a sweated earth onto the lead sheath of the cable, etc., on a pilk or whatever, and you think, yeah, that's TNCS. So everything you've learned over the years, and you think it's TNS, no, you can't treat it as TNS unless you've got something in writing, I would suggest, from the DNO that actually states it is guaranteed and it's not going to change. There could be a situation where you've got a transformer that's on site. So
I was just going to say that, good point.
Yeah. Talks about that. If it's got its own private transformer, that's fine. And if it is TNS, all our problems generally go away. Because if it's TNS, we're allowed to connect the equipment, whether it's inside, outside, whatever. But the same with any installation or additions, we've got to make sure that the current earthing and bonding arrangements and all that meet the current requirements for TNS systems. So TNS, good.
So it would be ideal if we had access to it, wouldn't it, really? What do you reckon, Craig?
For me, I just think in my experience, every time I've checked this or tried it, they've always just said you have to say it's TNCS and go with your precautions and look at installing other protective devices. So as great as TNS is, chances of us ever actually getting to use it when it comes to car chargers is probably slim to none. And I guess that's why we need to start to look at some of these other devices and around there, because 95% of installs people are going to have to treat in a TNCS fashion, and therefore that's the one that I often spend time kind of focusing in a bit more on. What are pen faults? What are you looking at when you talk about touch voltages? Why are they different on EV chargers compared to generic kind of 50 volts and 70 volts? And sort of trying to explore a bit of that beef around there, because ultimately that's the thing we have to make sure they know, because as great as TNS is, it's not likely, so therefore it's making them aware of that, because I don't always believe, bearing in mind, even though this is for competent electricians, I don't always believe they come in with the understanding that even if it's TNS earthing in the house, the car charger has to be treated like it's on a different earthing system. And that often causes confusion in my experience.
I would definitely echo that.
Yeah. Courses I've run, that, a lot of electricians kind of opened their eyes and went, "Oh, okay. Okay." So if you've got to treat it as TNCS, when we look at the next section, 5.2.4, it talks about TNCS systems. So this is where we've got a line and a PEN conductor, a combined protective earth or earth neutral conductor. And there are particular requirements for EV charging installations that form part of one of these TNCS or PME systems. So there has been a change to the next part in Amendment 2. So in the Code of Practice, it's referencing 722.411.4.1, and it says that a PME earthing facility shall not be used as a means of earthing. So we're not allowed to use it if the charging point or the vehicle being uncharged might be charged outdoors or the charging point is outdoors, unless we use one of the following options. So in the Code of Practice, there are 5, but we know in Amendment 2, they got rid of the first option, was where we've got a perfectly balanced 3-phase system and da-da-da-da-da.
Good luck
so they
with
got rid of
that
one. Good luck with that one. Which left 4 options. 3 of the options were based upon some new kind of device, which monitors the voltages between different points. And the second option is where we supplement the PME earthing system with a supplementary electrode system. And it gives us numerous formula calculations in one of the annexes at the back of the regs. I've done this calculation a few times. Depending upon the load, you're generally looking for a value of under 1 ohm, which is going to be extremely difficult.
Copper ore in the ground.
So you end up with generally three options. Even in the Code of Practice, there is a note, though, that references these 3 new devices. And we had a bit of a conversation about it in the last podcast, where this device, there is no product standard for it as yet. And because the regs doesn't specifically deal with equipment, because it's outside the scope of the regs, we are responsible as the designer or the person that specified the installation to make sure that this new piece of kit, this new monitoring device, has been made to the appropriate safety standards and directives and all the rest of it. So what we've got to get from the manufacturer is this conformity or certificate of conformity, because there isn't a current piece of test equipment that can test this new open monitoring device. We could go to the cutout. I'm not suggesting we do, but we could. And we could take the cutout apart, which we're not allowed to do, and cut the pen and let's see if it works. But we can't do that. And we can't test it because we don't have a tester. In Amendment 2, of course, it's moved on further from that, and it actually states that we have to include that with all our certification and paperwork. And we said in the last podcast to try and get this document or paperwork from some of the manufacturers is proving to be quite difficult. So therefore, does it comply? Are you happy that it's going to be safe?
Yep, good point. And it's one that needs to be properly accounted for, isn't it? Go on, Craig. Carry on.
And it's always
You're lagging behind us a bit, mate.
I'm always at the back of the queue. It's fine. But it's people aren't always going to be coming forwards with it, and then that leads you in a real predicament, doesn't it? Because We can't test it. How do we know? Taking people's word for it isn't really going to stand up if you ever did end up in a situation in court. So what's the choice, I guess? If you don't get it, where do you go next? Because all these manufacturers are claiming great things that their chargers do. And I really enjoyed Monday Club's episode this week because they had EV Nick on there. And I was enjoying listening to some of his opinions and takes on some of the different types of chargers and some of the pros and cons. And actually, it makes you realise that if you are entering this world, I don't think it's one of those things you can just dip your toe in, because there's so many little bits that are going to catch you out that you need to actually be kind of all in or kind of staying away from it, personally.
Yeah, I agree. I think that podcast was fantastic. EV Nick is a brilliant channel. If you're not aware of it as well, go and check those guys out on Monday Club and EV Nick. He really understands the products. I think he said he's had about 20 or so through his hands, and they do vary massively, don't they? And they do vary massively on who'll produce the certificate of conformity as well. So it is something to be aware of. And I guess the solution, if you're not going to accept that, is to start looking towards TT earthing, but sometimes that can bring more problems as well, especially if you're around other installs with PME, and we'll get to that in a minute, I'm sure.
As just pushing the conversation. Sorry, I was going to say, isn't the conversation with TT just going to become the next industry's hot tub saga?
Well, mine still leaks after I put a rod through it. But there is a note following on from those options, and it actually reminds us that creating a TT earthing system for the equipment, or maybe we've converted the whole installation as an alternative to using the PME facility, may not be an appropriate solution, because you've got to think about separation distances above the ground between two different earthing systems and a difference in potential, but also you've got to make sure you've got sufficient separation distance from buried metalwork, extraneous parts, etc., that are still connected to the same pen. And if you've got, and there is some further guidance in the book, which I'm sure we'll move on to in another podcast, but unless you can guarantee that separation, you're going to get some of this circulating neutral current, depending on obviously the impedance or resistance, is going to flow in different directions, and then you could end up in even more pain or more problems. So it's quite complex. You know, you can go into a lot more depth with it, but where we used to just say, you know, I'll separate the charging equipment, I'll put an electrode in just for the charger. I've got rid of the problem. There's obviously been issues with that in between the 17th Amendment 3 and the 18th, and then Amendment 1, especially, and now 2. It ain't a solution.
We've lost Craig. Hopefully he joins us back in a sec. We'll keep an eye on him dropping in. But yeah, I think you made a good point there with the TT stuff. It is a big issue. If you think of a car park, for example, and I'm going to use a railway station as a prime example, because I've been speaking with Neil about this. He's been looking at solutions for that particular environment. And if you've got lampposts that are TT'd, as they usually are, they've got a local electrode, and if you're bringing out a charge point that you're putting onto a PME earthing system, even with the pen fault detection, you've got those two earthing systems in close proximity to each other. So you've got a problem there. You know, you've got the issue, sometimes it's beyond the scope of your install. So you could be installing a row of charge points along a metallic fence. And on the other side of that fence, the occupants in the building adjacent have got some lighting on there, or, I don't know, some socket outlets, whatever it may be, and they've chosen to earth them down as an extraneous conductive part. And then you've got the mixture there as well. And like you said, in a domestic environment, we've had this argument about hot tubs loads and loads, but if you go driving rods into the ground in most kind of urban areas, getting separation from the PME earthing system is actually more difficult than lots of people understand, because all those buried services are in and around us, and getting 10 metres away from all of them with one rod is a shot to nothing. You're probably not going to get it. You know, you'll see people say they've had an earth rod in the ground and they're measuring under an ohm. Often that's because they've gone through a metal water main or something, or they've hit some metal in the ground that's tying them back to the PME.
It moves on from that then, and just reminds us about what a PME supply is. And there's a nice drawing and what it looks at, and tries to explain, you know, a loss in the pen conductor, etc. There is some great information on the IET website, and there's some great videos that they've put on. And they did a publication the IT, they produce that publication, don't they? Connections, whatever it's called.
Yes.
And I always use that, and they've got some animated videos that they've got, and they simulate breaking the pen in different areas and how it affects the voltage between 2 points and the current. And I always reference that and use that in my teaching because it reminds sparks and new people into the trade about what that will look like and what can happen. So there's a good image of that, what goes on. Reminds us of the bonding requirements for PME systems, reminds us of the sizes, referencing obviously table 54.8 of the regs. So pretty good with that. And then it goes on and it starts talking about some precautions about to be taken for PME. So 5.3.2, it says you've got to look at section 6, 7 and 8 because there may be some more specific requirements for on-street, commercial, etc. Talks about then suitable protected devices have got to be used. In other words, one of these new open devices, etc. Gives us information then about converting to a TT system. So there's some more in-depth information about converting the whole installation or just converting or changing the charging point into TT. And it talks about what we've just spoke about, separation distances. And if we do decide to put a TT system in, there are some forms, some risk assessment forms that we have to fill out. Those are included in the back, in the annexes of the guidance document. You can buy them again off the IET. But I don't think there are many people, especially in heavily dense built-up areas, where this is going to be an option, TT. So
it does feel like the regulations and the guidance is pushing us towards these open protective products, device. Isn't it? It's like the only real viable solution in most cases.
But there could be a situation where you've installed, I don't know, some EV chargers out in a remote car park where there's no other buildings close to it. You know that your PME supply's in. There are no extraneous parts, so there is no separation below the ground or above the ground. Then there's no problem. It's not saying you can't use it.
No.
It's an assessment of risk, and you've got to take into account all the factors that could cause you more problems than not. So there could be, times when you could still TT. So there is some good information on that one. Of course, if you convert the whole installation to TT, you're then going to not achieve your disconnection times anymore. So you're going to need to have RCDs for fault protection and, getting coordination and selectivity between those in a big installation. You might not be able to do that. So that could be a problem. Talks about you could use the protective measure of electrical separation. It talks about that. You need an isolating transformer. The last time I looked, about 300-400. Yeah, go on, Craig.
So I just wanted to jump in on the TT point before we went on. I listened to an NIC webinar this week as well about one of their update webinars they're doing around the 18th edition, and the question was asked around, this new foundation earthing and people putting rods into buildings. And they actually said that they are advising against it because we don't know what the DNO have got as far as PME earth rods under the ground. So by putting a TT rod in, you are potentially making it worse because there might be other rods involved in the PME system, which is then starting to affect the installation that we won't ever know about. And I just thought it was an interesting point to say where people think they're making it safer, you may be making it worse because of what is going on in the actual supply coming into the building. So TT for me is a bit of a dodgy option, unless, as you say, you're out in the country somewhere, maybe farmers' fields, something like that, where you've got nice big wide open space. But in built up areas, we could be doing a lot more damage by looking at a TT option than we are doing benefit.
Plus, like most things in the regs, it references other standards. So when you look into BS 7430, which looks at earthing and bonding standards, you're getting into a whole new world of more technical content as well. So I think you've got to be very careful with, mixing earthing systems and, zones and, voltages and diverted currents and things like that. It's a bit of a minefield. You've got to be careful. So, yeah.
The easy solution is to use the Penfold product to make sure you get the conformity.
I was just going to ask you, Mark, because I haven't installed many chargers. I haven't used much of the open technology. So how do you find it from a spark and install point of view?
straightforward, to be fair, Craig. Generally, the installation process of a product that's got pen fault detection built into it is no different to one that doesn't. It's just something that's there kind of working in the background. And as Richard said, there's no real way of testing it other than kind of messing around with the supply arrangements, which isn't something that's advisable. To be fair, the Mate product does now have a test feature in it. I think I mentioned it on the last podcast. That just interrupts the line conductor, so you can swing a little switch over. It'll take phase 1 away on a 3-phase charge point, and then the pen fault detection device sees that and opens. And then it will also check for when that's disappeared and reinstate itself now, which has got people a little bit upset because auto-resetting devices are never something that's greeted with open arms. But I think as long as it's not resetting because of an earth fault or a short circuit, overcurrent protective operation, it's okay, I guess, if the fault has definitely cleared. It does involve reduced involvement of people coming out for maintenance just to reset pen faults. I think that's probably sensible, but it has caused some discussion.
Yeah. And of course, this is.
And is it then Sorry, I was going to say, is it then the same sort of selectivity considerations between that if a charger claims it has it in, but you can't get a certificate of conformity, for example, and then you put one in as an extra measure? Is it like an RCD selectivity situation where there could be issues or a bit of nuisance tripping, or don't we know?
That is such a good point. That is something I've not thought about, and that is such a good point because we worry about that with our overcurrent protection, our air fault. But yeah, if you put in a Mate, for example, in front of a charge point that claims it's got pen fault that doesn't have the certificate of conformity, what have you selectivity have you got on that front? I've never thought about that. That is a good point, Craig. That is one to put back to industry, I think. Good shout.
You've got to think about integration of devices from different manufacturers. Are they compatible with each other?
Mm.
I
think we're opening a can of worms amongst ourselves there, aren't we, to be fair?
I'm not sure we answered anything in that.
The other option we've got is to use the protective measure of electrical separation, where we can supply the charger effectively from an isolating transformer. So that is an option. And I know some of the Mode 4 chargers have an isolated transformer in the bottom. So there is another option. But, domestically, you've got to buy another box and you've got to raw bolt it to the wall in the garage because it's going to be a heavy transformer. And you could do it that way. But is it the easiest option? Probably not. But it is another option. If there's no way around it, we could do it that way. Could do that. Then it talks about the conformity in terms of, what we're kind of looking for if we're using one of these devices. Gives us, in Table 5.2, some examples of different standards that you might come across. But again, that's down to the manufacturer, isn't it? They've got to provide that information to us. It then talks about these new voltage measuring or detection devices, and they're either going to measure between the circuit protective conductor of the circuit of the charger or the charger itself and true earth, or another option is where they measure between live and neutral, or another option is where they measure or they get a point derived from the 3 phases for a 3-phase system. So it gives us a bit of information on these different devices. It gives us some nice pictures on what these might look like on figure 5.4. So there's a 3-phase version, where you've got this reference point derived from the 3 phases, which in effect is the Mate unit. That's the technology that they kind of use. And in effect, it's a contactor, isn't it, that opens line L1, L2, L3 neutral and the protective earth all at the same time. We've got another device that measures between the circuit protective conductor, the protective earth of the circuit and the equipment, and true earth, what we stand on. And it uses a measurement electrode. But then there's problems with that. So there's only one manufacturer I know that used that, and I forget what they are called now, but there was an interesting 5 or 6 part video on eFix that they did. I forget what the manufacturer is.
I remember it. The manufacturer escapes me as well, but I remember watching that. I've never installed a product that has that in it, I've got to say.
No. And that's the only product I know that uses that. So you've got options there. Then it talks about, and I quite like this page because you can see in my book, this one, I've got quite a lot highlighted there. Look, I quite like this page in particular. This is a nice one, page 39. And it talks about using a protected device which complies with Indent 4. So this is the one for single phase charges only that measures between live and neutral. So this is where it takes its measurement from. If it falls below 207 or above 253, but no more than 5 but less than 4, it will trip the device. But it does say this type of device detects most conditions, most, not all, most, that arise when there is a break in the pen conductor in the distribution network. Goes on to say, however, where the installation is supplied from a 3-phase PME distribution network, and I think most single-phase supplies are, aren't they? Mm-hmm. Which is usually the case, there are a small number of conditions in which the line to neutral voltage will appear to be within those tolerances, 207 to 253, but the voltage on the PME earthing system has risen above 70 volts. So this technology is not always safe. And again, another great video that eFix did with Dr. Chris from My Energy, where he's got a rig that he built, where the touch voltage is way higher than 70, but the device hasn't tripped because it's still within 207 to 253. So pretty good. So I like that. And lastly, it talks about if you've got a device that requires regular checking, in other words, a mechanical device like a contactor, we must include suitable information with the handover documentation. And I know when the first MATI units come out, there was quite a few of them buzzing, wasn't there? And
there was
making a chattering a noise. So that was to cover that. So indent 3, indent 4, and then it talks about, it doesn't actually talk about indent 5, does it? No, but indent 5 was another option, and that was the last option. And so some manufacturers, like My Energy, have chosen to use a new way of doing it that's not indent 3 and not indent 4, but something new, and they'll declare in their documentation they're using indent 5. And that paths or provides a path then for other manufacturers to come up with innovative new solutions, indent 5. Happy days. Talks a bit about open devices and prosuming in island mode. So they've introduced us 5.3.5.5 to part 8 before part 8 came out. So basically, some of these devices might not work if you're in island mode. But again, you've got to go to the other standard, the other energy, whatever book anyway. Then it talks about general requirements for circuit design, cable collection and cable selection and dimensions. So right type of circuit breaker, do you need a suitably rated RCD, isolation, emergency switch maybe. And it goes on to say it is a requirement, regulation 722.311, a separate dedicated final circuit shall be provided. So it must be done, must be on its own circuit. So I couldn't decide to spur off an existing ring final circuit, etc., etc. We are allowed to have more than one charger, though, on the same in a separate circuit, as long as we don't go over the rating of the cable, basically. Bit on cable selection, cable type, standard stuff to do with the regs. Got to think about, obviously, protection against electric shock, overcurrent protection, volt drop. So that's our standard cable calcs that we should be familiar being able to do.
And then we've got the best form of protection. Go for it, Craig.
I was going to say that I do think at that point with RCDs, it's worth talking about them being double pole disconnection. And
yeah, that's the next bit. So cable selection and all that is fairly straightforward. I do mention, though, when I used to deliver the course for this, that if you're using a cable like Ultra EV or something provided by Doncaster Cables or something like that, that's not currently recognised by 7671, because there is no product standard for it, you'd have to put it down as a departure in your certification, because it is a departure, isn't it? It's not recognised, but as the designer, you're saying, I'm going to use it, and I'll follow the manufacturer's instructions, but it's no less safe than putting in SWA and running a separate Cat6 along with it. It's probably safer. So there is that. I always mention that, because there are these new cables now, aren't there, that are coming out, etc.
Yep, good point.
Then protection against electric shock. Big thing, basic protection, of course, as standard. We've got to use ADS, or we can use electrical separation. Additional protection then, good bit of information now, and it starts talking about RCDs.
I think that's the biggest, most exciting part of the EV training, isn't it? The RCDs.
Yeah. So 5.6.1, it says for each connecting point, so each outlet, each point, they must be individually protected by a 30 milliamp RCD. But the RCD has got to comply with one of the following product standards. So BSEN 61008, BSEN 61009, BSEN 60947-2, or BSEN 62423, which is for type F and type Bs.
And this is where a lot of the
RCD
EV charge points fall down, isn't it? Because they don't actually have that in them.
That's standard. So if the manufacturer of the charger, if you look on their tech specs and you don't see those product standards, you're going to need to install one upstream. Simple as that does comply with those product standards. Then it says, what else we got? It says, RCDs then shall disconnect all live conductors. So if it's a 3-phase RCD, it needs to be 4-pole. If it's single phase, it needs to be double pole or switched to neutral. Now, not all RCBOs are double pole. When you look at the device, and you find that out by looking at the drawing on the side, and to help me in a lot of my guides and books and stuff like that, I reference other documents, and the Beamer documents are exceptional, I think, in breaking things down with nice, pretty pictures. And bearing in mind that this guidance book came out before Amendment 2, okay? So it didn't have all the symbols that you would expect to find on these devices to indicate what type they were. So, as I showed Mark before, I've got the different types, and then I've cut out the pictures from the Beamer document or other documents I've found and glued them in. Because then I can say type A, yeah, I'm expecting to see that symbol. So it's good for AC, but good for pulsed DC, etc. On the sides of the RCDs or RCBOs, you'll find you'll have these, where are they? These, like wiring diagrams, which will indicate whether they're single pole or double pole, because they're not all are. I mean, some of the manufacturers, you need a different product code. So you might think, yeah, it's a Schneider device. Best in the business, love Schneider, 60 quid for an RCBO, single pole, no good.
Just to say to a lot of the apprentices who will be listening to this, some of the descriptions of RCBOs, it will say line and SN, and some people assume that means switch neutral because that's what the RCBOs are termed, because they don't have overcurrent protection in the neutral leg, but it actually usually means solid neutral, so it doesn't actually open the neutral on operation. Most of the older RCBOs used to have solid neutrals. They're kind of all moving towards this switched neutral now, but you've got to check, and the only way to properly check is to look at the diagram, read the literature with the products or before you order, because you don't want to be putting something in that's not going to do the job.
There is a nice note that talks about single module RCBOs may not be suitable because there might be a solid link as opposed to, switched version of, because it needs to break both poles, or 3-phase or 4 poles. So good bit of information that is, to be fair. It does say, though, that we're not obviously allowed to use type AC. It's either got to be a type A, an F, or a B. That's what we can use. That's the only thing we could use. And with the RCDs, it either needs to be a B, or it can be an F or an A, but you need to use that in conjunction with this new residual direct current detecting device, an RDC-DD. So, again, manufacturer of the charging equipment, what's built in, what's not. That makes sense?
I think Craig's waiting to jump in. Go for it, Craig, because he's on a lag.
Amendment 2 obviously has good diagrams and sections in the back of the regs now about selectivity of RCDs. So if there is supposedly a Type A RCD inside the charger, fitting a Type A RCD back at the board maybe isn't then going to be the best option, and you might have to start looking at increasing to some of the other types of RCDs along with that to allow for that to take place. So it's always important to look at the appendix and the regs as to RCD selectivity when doing this, to make sure that you are choosing one that is suitable and compatible with what you are installing at that point.
I agree. Let's explain a little bit about what those different RCDs are. I think it mentions it on page 43 if you want to run through those, Richard. Yeah, I think it's looking at the different types and what they all do.
Yeah. So type A RCD, and again, that'll be represented by the symbol that's on the device. So if you're not sure what this device is, it's represented by a symbol. It doesn't say type A, it's represented by a symbol. So type A is an RCD for which tripping is ensured for residual sinusoidal alternating current. So it does everything that an AC does, and everything to do on the AC waveform, perfect. But it can also detect residual pulsating direct current, so pulsating DC up to 6 milliamps. So it does everything an AC does, but it can deal with pulsating DC. Happy days, because most equipment now that we find in most of our installations have some kind of semiconductors in them, don't they? Electronics. There's electronics in everything. So a type A. A type F does everything that an A does, but it can also cope with high frequency residual composite currents, basically. So maybe a VSD drive or something in a washing machine or other high frequency fault currents, a type F can deal with. A type A can't, but a type F can. So a type F does everything an A does, but more. So a type F is obviously more expensive than an A. I've never seen a type F yet, but there you go. A type B then does everything an A and an F does, but with one of these, you can have AC, pulse DC, and direct DC. And in addition, they go up to 1 kilohertz, and you can use them for pure direct current and residual currents from rectifying circuits, three pulse star connections and bridge rectifiers and all that. So a type B is the best protection, but of course a type B is a very expensive device. So if I don't have this RDC DD device in the charger, in theory, anything above 6 milliamps of DC could make my type A ineffective or stop it from working. So I'd need to have a B. The idea with this RDC DD device is that it will trip or disconnect anything over 6 milliamp. So if it goes over 6, my type A can deal with up to 6, but after 6, this device will trip.
So essentially, that's making it kind of impossible to blind a Type A RCD. And I know from when I used to install the first Tesla, I think it's Tesla Gen 1, they used to have a Type B RCD. It was specified in the manual for that product. And I think now as we've moved... They weren't cheap. They weren't cheap, which is why not many people went for the Tesla charge point. They get the Tesla car and they wanted the charge point to match, and all of a sudden when they see the difference in cost between that and a Zappi install at the time, for example, they change their mind.
But
very expensive. Well, yeah, go on, Craig.
Isn't that like a similar analogy to buying the expensive car and fitting it with budget tyres?
I suppose, although the Tesla charge point never had the greatest reviews, to be fair, without wanting to get myself in any trouble with any CEOs or anything, that was, that was something that wasn't a popular option among a lot of consumers.
So those are your options. So you either need an A and an F in conjunction with an RDC DD device, and some of the chargers have that built in, or if it doesn't, you need a B. So those are your options that you've got. So you need the right type of RCD, and it needs to be double pole. That's the key.
So sometimes trying to comply with all this, you can end up with your RCDs stacked up in series, can't you? So you could have your pen fault protection stacked in series because you're not meeting the right conformities. Then you might have an equivalent of a Type A RCD in a product, and then an external one as well. And when you look at all our regs and it talks about selectivity as a big thing, it likes us to try and ensure we've got bits of that kind of stuff from the start, aren't you?
The other consideration you've got to make as the designer is that, and it doesn't tell us in this guidance note, but it does tell us in the Beamer document for selection of RCDs, brilliant document, that we cannot have a Type A upstream from a Type F, for instance, or a Type A upstream from a B. Or you might go to an existing installation that has Type AC RCDs, and we can't therefore have a Type A downstream from an AC, because in effect, that DC won't damage the Type A that we've installed, but it could leak back or may leak back into the system and make those Type ACs ineffective. But it doesn't tell us that here. That's another consideration we need to make.
Another good point, going off and checking your other documentation in other places. That is such an important thing that often gets missed, isn't it? So, yeah, well, good point on there, isn't it?
And then to finish that little bit off, talked about the label, obviously for an RCD to remind the user to press that every 6 months. Bit of information on emergency switching, but it's not normally required because of your 30 milliamp RCD. And a bit on isolation, functional switching. IP ratings is a good one. It's always a conversation that I have with the lads. So IP rating of equipment minimum is at least IP44. And again, you need to find that from the documentation of the charging manufacturer. Most of them are at least IP65, at 68 maybe. But the minimum is IP44. Interesting that it also talks about, and this trips a few people up, is 5.8.2, looking at IP rating of the installation components. And it says the installer shall ensure. So any connectors, glands, conduit, female adapters, anything that you're going into this enclosure with. So if, let's say we're going into a charger and it's got an IP rating of IP68, in that charger, of course, there are going to be lots of sensitive electronic components. So that charger, the box, the enclosure that the sensitive equipment's in is rated at IP68. As soon as I drill a hole in it and put a cable inside it, I've broken, or, that IP rating is gone. So what it's saying is, if I'm going into that enclosure with an SWA gland or another type of gland, it must have the same IP rating as the enclosure. And people don't realise that even outdoor glands don't have an IP68 rating.
No, there's very few of them that will actually meet that. Yeah.
Because certainly I've installed a few of the Zappi chargers, it is obviously a circuit board full of all sorts of chips and electronics and diodes and all sorts of stuff. Any moisture in that, in effect, because I've left a hole or done something I shouldn't have done, could cause that to malfunction or not work correctly, could invalidate the warranty, but it could, if it's got an open device built into it, it could kill someone. So, my energy are that specific. You even get torque settings for the screws on the lid, don't you? With the seal around it. That's how critical ratings and using the right equipment to make your cables off or go into these enclosures. It's important. People don't realise that. So that always comes up.
Yeah, that's a good point, and it's something that isn't considered enough. Certainly on some of my installs, you're sometimes rushing on with a job and you need to just double check that you are actually making sure you meet the IP requirements, like you said, of what you're drilling in there. Don't just go chucking a normal outdoor SWA in, because sometimes you're causing yourself a problem you don't really need.
So, it's another consideration. And then, nearly finished this little bit, it talks about impact, and I've made a mistake in our guidance note, because it says the minimum impact severity of AG2. It's actually not. The minimum impact severity is AG3, which is IK08, isn't it? And they've made a misprint there.
Oh,
it should
okay.
be AG3.
Good spot. And I guess that's looking at, is it barriers around the products if you've got them out in a car park, making sure they're protected from something running into it?
Yeah. Just, if you drive into the thing or, bumper hits it or something, it's, barriers or, the actual ABS body of it or the plastic or whatever it is high impact in it. So if it does get a whack, it ain't going to crack and break and things like that. And then it talks a bit about socket outlets and connectors, refers us back to 2.3. Talks about lightning protection systems. Again, it talks about running a protected bonding conductor to that system. Talks about installations having alternative sources of supply. So energy storage systems, island moding, backup generators, and uninterruptible power supplies, UPS. You've got to then, consider that the means of earthing will change, and it refers us then to the code of practice for electrical energy storage systems, 9.4.
We've all seen those pictures from festivals where they've got diesel generators running an EV cars charging.
Yeah.
I guess that's what that's on about, is it?
On about things like that, or an actual UPS system, So again, it's kind of giving us a little bit of an introduction to other considerations we need to think about. Basically, those, that's section 5, in effect, basic electrical requirements. There's a couple of things that I think they've missed out from there, or two considerations. One is, would you consider that if this charger or in your circuit you've got one of these open devices and that device is there to protect somebody's life? If the open or the pen was to get severed or broke, would you consider that open device is going to protect someone's life? Is that what it's for?
In that circumstance, then yeah, it could be, couldn't it?
So, therefore, does it require a transient overvoltage device? Does it require an SPD?
You would say so, and I would say in more modern times, a lot of the charge points have Type 3s built in, but definitely up front of your installs, you've got to be giving some serious consideration to making sure you've got SPD protection in there.
Because that's often a missed point, isn't it, of people don't look at SPDs taken outside of 10 metres. They generally need to have further SPD protection fitted to support that. They only have a short radius of where they work, don't they?
but just a little Type 3 device, But there was always a bit of confusion in the 18th Amendment 1 and then Amendment 2. The wording's changed a bit, hasn't it? But it always said it shall be installed if there's a risk to or serious injury or loss of human life. And if that OPEN device is not working or functioning correctly because an overvoltage has fried the electronics in it somehow, and somebody loses their life, a question will be asked as to why a device hasn't been fitted in accordance with 443.4.1. So
that's a good point.
I think that's a no-brainer. Yeah, because this book is for EV charging, but it thinks that you've already got a good understanding of the regs in general anyway.
Yeah.
But I do mention that and bring that point up with the sparks. And the last thing to consider is an AFDD for a vehicle charger. And the reason I talk about it is because this outlet and this lead and this plug are going to be exposed to the elements. They're going to be plugged in and out quite a bit. Somebody could run over the lead. So is an AFDD a good recommendation for an EV charging circuit?
We had this discussion recently.
Is it classified as a socket?
I think if it's untethered, and that kind of defeats the object for an AFDD for me, that there can be some argument that it is a socket. The tethered leads, people are trying to say that it definitely wouldn't be a socket, but like you said, they're far more likely to have damage to those leads because they've been wrapped around the charge point over and over. They're left outside. They could be getting run over or snagged with someone walking past them. So in that circumstance, you can see more benefit. What do you think, Craig?
I think we should just leave it with a bit of an open-ended discussion of, do AFDDs even work yet?
We're talking about the recalls now. Me and Richard mentioned this offline.
I was talking to Mark, and I was at the latest LX show, having a good chat with Ian from Hager, and had a look at their new device. And I tell you what, it's a clever piece of kit, very clever, very very clever. There's a lot of R&D going into that, but who knows? I agree. On the fence. But as with anything in our industry, if it's going to make something safer, you've got to go with the flow, and see. But there's a lot of R&D.
100%. But I know a few people in industry who have put a few of these to the test and are finding that actually the results are not necessarily what it says on the tin. I think AFDDs in the future will have huge benefit. I think that they may be released before they're ready, potentially, in most cases. And I think the one particular manufacturer showed that this week with their product recall. Is it something I would put on a charger? I'm not sure at this point in time I actually would, if I'm honest.
Yeah, that's good, yeah.
I just did an install last week, and I showed it on my YouTube channel of fitting an AFDD on one, just to mess around. We've actually recorded some other footage since to see if we can upset it through normal use. One of the big issues with the leads, a lot of the untethered chargers will tell you to insert and remove the lead on occasion to clear the terminals up because they can suffer from oxidization. And often people will plug a lead in and just leave it there, wrap it around the charger anyway, so it might as well be tethered. It was to try and see if we could upset the AFDD, pushing it in and out, or trying to put a bit of Vaseline on some of the terminals. We were messing about quite extensively and we didn't manage to upset it. So we're going to take it to the next level and try and put some real faults on there and see if we can make it operate. Bit of suck it and see. And I think it's going to be a learning curve for us with those products. And I think, unfortunately, it's electricians who are going to have to deal with it, isn't it? So you have a product recall where you have to go and physically swap it. Obviously, that's our job. And who's going to be paying for that? The consumer who's got warranted products, or the manufacturer? And what are they going to pay us to go and do it? And even if we've got to go and update software on a device over Bluetooth, we've still got to physically revisit and do that. So I think there's a whole can of worms there that we're building into industry for the next couple of years, and this is something we need to be really careful with.
Well,
with the same argument, I've seen a couple of pictures of a couple of Zappy chargers where the outlet has burnt because someone has bought a lead off eBay, and obviously it's not made to the same spec. So the tubes, the contact tubes, are slightly smaller, and it's been overheating and getting hot and arcing. So because you can't stop, everyone will buy an alternative Apple charger because an Apple charger is 30 quid, and I can buy another manufacturer for 15 quid. But then is it made to the same standard? And you can't stop that. But could that be an issue? Something else I've seen recently, and it's all melted, and I thought, well, what's happened there? and it was because they bought a different lead, and it obviously wasn't made to the same standard. So, don't know.
I think there's lots of food for thought there for people to ponder with, isn't there? I think there's been probably more questions than answers come out of that, but a good discussion. I feel I've enjoyed it.
Yeah. So part 5, that's kind of cool.
It is. I think we've gone through section 5 in great detail there. Richard has led the way on that, so thanks very much. I think we've done it justice, and I've certainly learnt a lot sat here just thinking about things myself. It's one of the reasons I love doing these podcasts, and we're going to break it down into more little steps like this. I think it makes sense to break the book down, as we said before the recording. We'll maybe slip a couple of chapters together on some of the smallest topics. Is there anything anyone wants to mention before we end this podcast? I've got something I want to mention when we close it up, but anything you want to add, Richard, before we leave it there?
Not at all. I just hope it's been useful to apprentices as well as electricians and whoever. It's always available for a chat. Anytime if I can help in any way, give my interpretation of how I see it through my teaching and things I've learnt from good people like yourselves and other good friends in industry. But it's a minefield. Each part within part 7, you need a good general understanding, and the guidebooks are good, but they don't do everything, and that's why I try and get other information and stick it in if I need to. I'm not afraid. I paid 50 quid for the book. If I'm going to stick some stuff in it, I'll stick some stuff. Does it help me? I think it does. I think Amendment 2 of all the guidance notes and the regs is better, much, much better than it's ever been now. But there's still more they can do, but don't be afraid to stick a few bits in your stuff. You know what I mean? That's what I do. Try and,
Good shout.
Explain it better.
Anything, Craig, you want to add before we leave it?
No, I think I've enjoyed that tonight. I think I've raised all my points throughout, and we'll jump on any comments and discussions and see where we go next.
Absolutely. And for those of you who haven't watched the last episode with Tom Bickerton, don't forget the giveaway. I've shared some more stuff on social media about that. If you want to win a Hilti laser level or some Irazola drivers, you need to get on social media and start sharing your posts. We'll come back to talk about EV stuff maybe in 4 weeks or so. We'll be back with another guest chatting about industry next week. Thank you, Richard, and thank you, Craig, for coming along again. Thank you to everyone who's bared with us, and we hope you got some value for this. We'll see you on the next one.
Cheers.
Bye-bye.
Cheers.
Thank you for listening to the latest episode of the Apprentice 1-to-1 podcast, sponsored by Schneider Electric. Please like and subscribe to the channel, get involved with the comments, and we will see you on the next one.